This week we're going to cover a task I don't really enjoy very much, taking this and converting it into this, a mold blank. And I'm going to show you how I ended up crashing my machine and how I got around it. Welcome to another episode. Okay, let's go ahead and open the mold file. And the first thing I want to do is create a setup specifically to remove, basically to face off the top of the part and also the sides of the part. I'm going to rotate this and into a position that I like. Go ahead to Setups, Create New Setup. And for this, I want to have the width of the part be the same as the stock that I have. And then I want to add about 5 thousandths to the top so that when I surface it, it'll take 5 thousandths off. So I'll go ahead to Stock and I'll make it a fixed size box. The width, I measured it at 155 millimeters, so it's a little bit wider than, whoops, I didn't mean to save that. It's a little bit wider than 6 inches. I used the millimeters just because it was a little bit more accurate than the inch scale. And then for the Z, what I want to do is I want to make it so it's taller. So I think if I go here and change this to offset from bottom, and then change this to, I don't want the round off, I don't think. Change this to 0.6, we can see whether or not I got that correct. And you can see that it filled in 0.5 here. I want that to be 0. And you can see now it's adding to the top. So I'm going to go back and change this to 505 to give me 5 thousandths off the top. And it's a little hard to see, but you can see it is above the top by a little bit. Okay, now that we have that, there's one more thing I forgot, which is to move the position of the coordinate system. I want to move it to the box point rather than the model, the stock box point. And I want it to be right here. I'm going to the precision of this part is not really important for the facing operation, but I'm going to use an edge finder to find this point, and then I'm going to use an edge finder here and here to find the center. Finally, what I want to do is a facing operation, and I'm going to choose my 1/4 inch end mill for that. I'm not using a fly cutter because I don't have my machine trimmed perfectly, at least between the forward and backward position. I have it trimmed pretty well left and right. So the fly cutter doesn't make it completely flat. Using a 1/4 inch cutter instead of a fly cutter gives me something that's just plenty good enough. Alright, so I'll go ahead and generate the toolpath, see how that looks. Now if I simulate it, well, I want to see how much of a step over it is. So I'll go ahead and scrub along here. I want it to show the stock. And I don't really like this color that it comes up with as default. So I usually change it from mirror to ceramic because I find that it's a little bit easier to see what's going on. Here it doesn't make so much difference, but later on you'll see it makes a difference. Anyway, you'll see that it's moving over more than I want. I want it to move over, I think the recommendation is about 70%. So I'll go ahead and change that. Go to edit this. Go here, and for the step over I want it to be 0.7 times the diameter, which is 1/4 inch. So now if I simulate this and scrub over, you can see that that looks good. It's about 70%. So we have a toolpath that's ready to post. I've never done this before. This is my very first time. So I'm going to say post, and then I'm going to select Mach 3 because I'm using Mach 3 to drive my mill. And then I want to change this location for the output. So I'll go ahead and change it to, I've created a folder called molds, and then I'll change this folder name to be SMT strip holder. Not a very creative name, but that's what I'm calling it. and that's where we'll put the file. So I'm also going to change, let's see, the program name or number, so I'm going to call this to top facing. And I'm not going to open it in the editor, I'm just going to go ahead and post it. And that looks perfect. Just checking to make sure that these it's tight on top of the two parallel blocks before I tighten it down. And now I'm going to pick up this corner here. And I have to pick it up here rather than here because there's not enough Y travel for me to pick it up here. You can see it would hit back there. Move it to the side. You can see how it's wobbling. I'm going to get it close. And then I'm going to use the, I have a little rotary dial here. So I'm going to use this until it just barely pops. And right now I don't have to be precise. I'm just showing this off. You can see how it popped over. That means I'm at the 0 point. So I'll set that on the screen. Alright, so I've set the Y0. I'll back off, turn the spindle off, which is, by the way, I have it set to the lowest setting, which is about 1000 RPM. And I'm going to pick off the left side. Okay, so I've got the left side. When I pick off the right side now, it'll give me a measurement of the difference. So pull up the Z, head over to the other side. Down with the Z. And let's pick this off. So I have to do a calculation here. Okay, I've calculated the distance. I took 6.1956. I've subtracted 0.1 inch because that's this is a 0.2 inch diameter edge finder. So what I'm going to do now is bring this up, set this to Z0 so I can go back to X0. Okay, so I just hit go to 0. And then what I can do is I can enter in negative 0.478, and then when I hit 0 after setting that in, it should bring me to the center. Alright, I've entered that. I'm going to hit go to 0. And that looks like we're at the center. So now I'm going to switch tools. Insert the 1/4 inch cutter. And I'm going to zoom out now and pan up so you can see what I'm doing up here. I'm going to change the speed to about 5,000 RPM, which should be this one here. Okay. All right. Just wipe off my hands because I get my hands dirty doing that. Don't want to get my cell phone dirty. And so I'll zoom back in, pan down, and let's set the Z height. So the way I set the Z height on this is I'm using a set screw. So I bring it up like that. What I want to do is want to go to about the center of the object. Bring it down. Then I'm going to get close. And now what I'm going to do is I'm going to cheat. So the first thing I'm going to do is turn the motor spindle on so it drops ever so slightly. I don't have ball screws on here, so there's a little bit of backlash in each of the axes. And then what I do is I let go of the set screw and drop the tool down. So now the tool is at Z0. I can click on set 0 on the Mach 3. And now it's all dialed in. So I'll go ahead and raise it. I'm going to start the spindle, and then I'm going to click cycle start, and we should see some chips fly. Okay, one thing I noticed is that it didn't go all the way back here, so I think next time I'll make sure that it covers a larger area and extends out a little bit. That I think I can just use a deburring tool to knock that off, and this is going to be the bottom side anyway. Anyway, this is really sweet. This is probably the fastest I've ever gone with this type of cutting. It's not super smooth because I probably need to get a new cutter, but you know, this will do. The toolpath that I just ran was using all the defaults in Fusion 360. I just wanted to see what would happen if I didn't set anything. And I think it was a little bit too aggressive. So there are a few things I want to change about the toolpath. And by the way, the reason I did that is because this is my first time using Fusion 360 with my Taig CNC mill. So I just wanted to see what happened. Let's go ahead and change it so that it's not quite so aggressive. So I'll go in here and I'll change this from the default of 2.6 mils thousandths per tooth to about 1,000ths per tooth, and that'll make it less aggressive. The other thing I wanted to do is change the overlap here. So as you'll recall, it didn't cut all the material up here. Now the reason it didn't cut it is probably because I need to align my tool vise, which I'll do before I clean up the sides here. In any event, I usually like to have it go just a little bit past the end of the stock. So the way we can do that is by going here to passes and then changing the stock offset. Now I'm going to show a cool way of doing this that I just learned. Rather than just giving a value, I can edit an expression and I can use tool diameter times 0.5. So what this will do is extend the toolpath so that it goes out a little bit farther past the stock. So if we simulate this, you can see that in a couple areas. One is you can see that this now overlaps by 50% over the end of the motion. But the other thing you can see is if we look here, it now goes past the end of the stock before it starts turning around. That's because I set the offset to half the tool diameter. Now given that we've done that, the other thing that we can do is if we go in here and look at the step over, as you'll recall, I changed the step over to 0.7 times. I actually reset this while I was off camera. But we can change this so that this is also 0.7 times the tool diameter. So what that means is now, when we look at this step over, it's going to be 70% of the tool diameter, no matter what the tool diameter. And there are a couple of advantages of that. One is if I decide to change the tool, it'll still behave the same way. The other advantage is if I decide to store this as a template, now in the template, instead of having a hard-coded step over, I'll have a step over that's based on the tool diameter. So that makes the templates a lot more usable. Alright, let's go ahead and switch to cleaning up the ends. The way I'm going to clean up the ends is by using a contour toolpath, a 2D contour. And first thing I want to do, make sure it's the same tool, which it is. And then I want to select the edge here and the edge there. If I hold down the Alt key, click there, and click there, now I have those two edges. I'll click OK just to see if it's generating toolpaths for those edges. It is. Now, because my Taig is not as rigid as a Mach, I want to make multiple passes rather than cutting this entire thing, because the entire amount that's left is about 50 thousandths. So I'm going to change it so that it makes passes of about 5 thousandths each. And the way that I can do that is to go back here to passes and then click on this button that says multiple finishing passes. I want to set the step over to 5 thousandths of an inch, and because I want to cut 50 thousandths, that means I have to do a little bit of math, so I'll tell it to do 10 finishing passes. And you can see this is doing 10 finishing passes. Now let's go ahead and check that. So I'll click on simulation, and then I'm going to scrub over here, turn on stock, and I'll go back to ceramic. So I'm going to scrub until it just goes in a little bit, and you can see, yes, it is cutting material, but it's not cutting too much, so that looks like it's the way I want it to be. The other thing I want to do is I want the cutter to cut below the bottom a little bit to make sure that if the thickness isn't exactly half an inch, it still goes to the bottom. And also, there's no reason to use the very bottom of the cutter. We just want to use the side of the cutter. So I can do that by changing the heights. Now, if I go to the bottom and I say offset of, I want to make it so it's obvious, so I'll do an offset of 0.1. You'll notice nothing's changed, and that's because the bottom is actually not showing up right now. But if we change this to model bottom, you can see now it shows up. And it's above the part, so that tells me I want to make this negative. Now, I don't really want to go negative 0.1. That's more than I need to do. So I'll go down about, I don't know, 30 thousandths. And that should be plenty to make sure that the tool is below the bottom. Okay, so that's pretty much everything that I want. And that means I can go ahead and save this toolpath. I'll post-process it. I already typed in side facing because I was practicing before this, so I'll just go ahead and say post. Save it here, save it again. Now let's go back to the machine and make some more chips. I decided to see what would happen if I took the toolpath I just created, the adjusted one, and do a spring pass. And as you can see here, things didn't go quite the way I expected. The problem is that when I have the vise installed, it limits the material that I can mill to 3 inches, or slightly more than 3 inches. I think about 80 thousandths more than 3 inches. So when I moved the tool out this way, it meant that I was going to hit the vise. So we have to take a different approach. I'm going to go and I'm going to change it back to stock offset to 0. And then what I want to do to get it to go a little bit past is to lie about the setup. So I'm going to edit the setup, and I'm going to make the total length, instead of 3 inches, I'm going to make the total depth about 3.1 inch. I don't want it to be centered. I want it to be offset from the front, I believe. Nope. I want it to offset from, oh yes, I did say from the front, but I selected the back. Okay, now when I do that, and we regenerate this one, you'll see that, let me simulate that. You'll see that the tool starts inside, which is just fine. It's 70% over. And then over here it's going to do a final pass. That's going to cover that side. So that will fix that problem. We'll go ahead and back to the machine. I'm going to fix the bottom, and then I'll mill the sides. And I'm going to fix the bottom off screen. I cleaned off the bottom with a final pass with the new tool path that worked perfectly. So now I'm going to try the sides. Final step for preparing the mold blank is to cut this side here as well as on the back. To do that, I'll create a new setup. This setup is a little bit different because I want the coordinate system to be over here. So instead of model orientation, I want to select Z-axis plane and X. And for that, this is exactly what I want. I'll click OK. So I keep that. I'll rename that front and back. And then I'll go ahead and edit it to set the stock the way I want. In this case, the stock doesn't really matter. So I'll just change the stock offset to, no, actually I'll keep it at, I'll set it to 0.1 for the sides. And then for the top, I want it to be 5 thousandths because that's how much I want to cut off. And that should do it right there. Next thing I want to do is add the facing toolpath. I'll go ahead and click on geometry. That looks good. See what we get. That's perfect, except that I want to change the step over. To be the tool diameter times 0.7. I'll go ahead and post this, run it on the machine, and that should be a wrap. Of course, as soon as I decided to stop recording, I got a hard crash, as you can see here. It took me a while to figure out what the source was. Turns out my machine does not have limit switches, and because it doesn't have limit switches, it doesn't know where the zero position is. So the way I can fix that hard crash is to go down here and turn use G28 to no. And then when I post this, I will get G code that does not have G28 in it. So what was happening before is the G28 was causing it to go to a safe position, but of course it wasn't safe because I did not have homing positions, so the machine had no idea where it was. Next time, we'll be turning the mold blank into a mold half, and then in the episode after that, we'll be trying it on the injection molding machine and see how it turns out. See you next time.